product, a number, or a variable. Exactly right. So the most important thing, I think we've said this before, but the most important thing is you can multiply by anything. Oh, I don't know what that is.
You multiply by account.
So you can multiply anything together, and it doesn't have to have like terms. That's the biggest difference between adding and subtracting compared to multiplying. And realistically dividing, but we're not going to talk about dividing. So you can multiply by anything. All right, that's huge. Then we talk about our kind of rules of multiplication. And again, I don't know if you have to write this down. But our rules of multiplication go way back to what we had talked about when we were doing integers again. And the rule said that if our signs are the same, right, we basically had two versions. The signs are the same, or the signs are different. Those are two possibilities, right? If the signs are the same, what is my answer going to be? My answer is positive. Doesn't matter which one I'm doing. Positive times positive, a negative times a negative. Two of the same answers, I always get a positive answer. But if the signs, oh, I wrote it the same. I'm losing that. Signs are different, what is my answer?
Negative.
My answer is always negative, right? And again, this is where it kind of changes a little bit from addition and subtraction. When the signs were different, we always used the sign from the quote-unquote bigger one. That doesn't happen in multiplication and division, realistically, again, in division, but again, we won't do division. Okay? So again, those are things that we've already seen before, but it's probably worth that we're going to say it again. Again, it doesn't matter which one comes first, it doesn't matter which one's bigger or smaller. If they're different signs, they're automatically negative answer. Okay, so basically, when you're multiplying by a monomial, though, what are we going to do? We are going to distribute. Remember that word? So distribute means that we're going to take that monomial on the outside of our parentheses and multiply it by every single thing on the inside. Okay, so when I distribute, if I distribute a number times a number, we just multiply. Okay? So if you have two numbers, you just multiply them together. A number times a number is still a number.
But just do distributive property.
Basically, we're doing the distributive property. If we multiply a number times a variable, or two variables together, how do I show that I multiply those together?
Put them right together.
Yeah, you just put them together, right? So put together. And that shows that we did do our multiplication, but we really didn't do anything, okay? So again, if we have 6 times x, my answer is 6x. If I have x times y, my answer is xy. And I just put them together. Up here, my number times a number. If it's 4 times 7, we just do that and multiply. Okay. So then the last thing is what Mr. Colbeck was bringing up. And now we're going to multiply the same variable times the same variable. When we say it this way, probably doesn't make as much sense, but when we say it this way, we're meaning that the base of my exponent is the exact same thing. What's the base of the exponent?
X.
Okay, the big part, right? So when we're saying here, same variable times the same variable, but now we're going to change the exponents. Okay, so if I was doing this in addition or subtraction, could I add or subtract these two things together? Can I add x squared plus x to the 4th? No, I can't really bring them together, right? This is a black cow and this is a brown cow. So I can't add those together. But in multiplication, I can multiply anything together. So what do I actually do?
Just
Add the
add
exponents.
the
Add the exponents, right? So same variable times same variable. Add the exponents.
Would it be 2x or?
And put on the variable. So what's my answer in this one?
X to the 6th.
X to the 6th. So one way that you might see this in your algebra book next year, or maybe even in this book, sometimes they write it as this, right? X 2 plus 4, that gets me my X to the 6th. And so basically I guess the challenge of this is to recognize which one that I'm doing and be able to kind of do that on the fly. But it's essentially, all I'm doing is distributing that monomial on the outside of the parentheses to every single part on the inside. So on the inside of my parentheses, if I had a polynomial with 6 terms, I'm going to have to multiply 6 different times. Okay? But again, then you just have to realize which version of this you're doing. Bless you. Thank you. So, here we go. Start out with my monomial on the outside being a number. 2 times, oops, I have 3, sorry. 3 times 2x plus 6y. So again, remember when we're distributing, sorry, I already read this, it's kind of ugly. I don't know if that was any better. We're going to take that number on the outside and multiply it by every single term on the inside. So what do we get?
6x plus 18y.
Plus 18y. Now, can I simplify this?
Yes.
No. Cow and a horse, right? So this right here is my answer. So again, that's where you get in trouble. You got to make sure that you slow down and you go back and forth between the two. So I multiply anything together, but then when I add and subtract, I only look for like terms.
What happened to your glasses?
What if we find a variable and it's the same, or inside the parentheses it's the same variable?
Then you can either do this again, or you can simplify it inside that parentheses first and then multiply. Because then you're going back to the order of operations that says P for parentheses, and I work inside out.
Type of profit makes no sense.
Okay? Just scroll that comments, D to N.
Okay.
So now we take a variable and a number on the outside. So 3x times 5 minus y. Now remember, the minus sign is actually the sign of that term too, right?
Yeah.
So my y in this answer, or this problem, is negative. All right, so again though, I'm taking the entire monomial and multiplying it by each part of the problem. So what's 3x times 5? 15x, right? So again, multiply the numbers, and then just bring the number and variable together. Now what about my y?
Negative 3x.
Minus 3xy. And again, it's not necessarily ever going to be wrong if I wrote negative 3yx, but we should try to always write it in alphabetical order. Okay? And again, so we got a positive times negative, so this turned into a negative. Positive times positive, it's a positive answer. Okay? So that would have been our second kind. And then the third kind, we look at taking another monomial, but now we have variables that have the same base. They're just different exponents. But we can now still do all these, right? So again, I'm taking my entire 2x and multiplying it by every single part of the problem on the inside. So again, now I'm doing a combination of two. I'm doing my numbers times my numbers, and then my variable times my same variable. I'm going to add my exponents. So, what'd you come up with?
8x cubed plus 16x quadruple.
I got 64x to the 6th.
Wow.
Wow.
That's how I simplified in the parentheses.
But I can't simplify in the parentheses
Yeah.
because why?
Different.
See how this,
adding.
this is a brown cow and a black
Oh,
cow
it's
still.
adding.
Yeah, they were adding on the inside. So unfortunately, we don't like to say this out loud, but Mr. Colbeck was right. Yay! Does everybody get that answer?
So it's 8x to the 4.
8x cubed plus 16x to the 4th. Okay. All right. Now, here's a couple other different things. Whoa, look at this problem. I forgot the number. Can't really do that. So what happens with the problem like this? This is really important, and I want you to notice this. In all honesty, right here, this problem right here is probably written the wrong way. Because why? Well, one, it's backwards, right? So if this being on the back side of the parentheses bothers you, just go ahead and rewrite it. But in all honesty, this problem right here is still even wrong besides it being written backwards. Because if I want this to be multiplied together, I really should have parentheses around that part. Because otherwise, it realistically, how you would have read it was 6x minus 1 minus 2x, right? And so that's a big difference. So you really got to make sure, and I think the book does a pretty good job of this, putting parentheses, but the things after your original parentheses, if they don't put parentheses on it, then it's actually a subtraction problem and not a multiplication problem. Does that make sense what I'm saying there? Okay? So again, if you have parentheses around this, you can still distribute. If that bothers you, just take 2 seconds and rewrite it. And when I put it out in front, then I really don't honestly need that parentheses around the negative 2x part. But do you see the difference there?
Yes.
When I take this parentheses off right here, that turns into actually a subtraction problem. Okay? So, in either case, what do I get in this one?
3x minus 12x squared, or negative 12x plus 3x.
Negative 12x plus 2x.
Yeah.
Plus 2x, yeah.
No, negative 12x,
Oh, it's 1.
negative 12x
Uh,
squared, right? X times x is x squared, plus 2x, right? So we saw a couple of the things that happens a lot, right? Don't forget, my exponents here are x to the first and x to the first. 1 plus 1 gets me 2. And then Mr. Colbeck, I think, added here. I don't know what it did to get 3, but
Yeah,
yeah, okay. Everybody good with that?
Yes.
All right, let's try this one. Let's do it way over here. 4, I'm going to change it to k because I don't like using b's. 4k times negative a squared plus 5ak plus 2k squared. Good one. So again, make sure you do the letters correctly and the numbers. So multiply each of the coefficients together and then look at the letters.
would you add the exponent of the k and the a together?
No. So this is a to the first and this is k to the first. So when I do this to this one, I'm doing k to the first and k to the first. Done.
So even on the first one, you would, like,
So this one, no, I'm just gonna, these two are different. So this one is like here, I'm just combining them. Okay?
So it's just when it's the same variable where you add the exponent.
Yes. The base of the variable. So in this one right here, when I do this k and this k, I'm adding those two together, but this a stays the same as a. All right, everybody think they got their answer?
Yes.
So again, I'm taking this times that. 3 different times in this case, right? So what'd you come up for the first one?
Negative 4K, no, negative 4A squared K.
Perfect. In all actuality, we should probably write it this way. Again, alphabetical order. Is it wrong if I write KA squared? No. But just get used to it. Try to do it in alphabetical. Next part.
28 A squared.
Perfect. Everybody good there?
Yeah.
And last part.
Plus 8K to the
8K.
8K cubed. Is that correct? Perfect. How do we do?
Yeah. Good.
Want to do another one?
Yes.
Okay. Let's do, make this one a challenge. There you go.
That's it.
That.
So what a 6? What do you think it is?
I didn't know.
I forgot, I was dumb, so I wrote bad letters. Grace called me dumb yesterday.
I didn't mean to.
Great. That's not 9.
And then she said it's because I remind her of her brother.
No, I said because I always call my
So
brother
basically,
that.
yeah.
And so it just kind of came out.
Uh-huh.
I tried to stop myself, but it was too
Uh-huh.
nice. It's not
That's not nice.
nice.
All right, Grace. My feelings were hurt, but that's okay.
I said I'm sorry.
Make it sincere.
I did.
Hey, where'd you get this?
I don't know. It was just there.
Stealing my sign?
No, it was just there. Yeah, you still need stuff. Jacob, you threw a piece of paper at me. No, I didn't. Yes, you did.
You can do it there, I saw you.
You threw it at me.
Are we done?
No,
Yes. Yes.
I'm done.
Are we ready? First term.
3H cubed. 6H cubed E.
Anybody disagree? You do disagree?
I got that.
Next term.
Plus 8H squared M.
Perfect. Awesome. Last one.
Minus
16H to the 8. I said that wrong.
Awesome. Questions here? So, this section right here is probably not that bad when you're doing it by itself, but then if we would throw them all together to go from addition to subtraction to multiplication to addition to multiplication to subtraction, that's when you got to really slow down and concentrate on what the problem is saying.
You just said.
Oh, what if you found like all the additional ones did those?
You could do that. That's fine.
And
All right.
finish.
Any questions here? No. All right, that's it. So you have 10 minutes to work on the problems.
I have no more pages left. Someone have an extra notebook?
Yep.
Actually? Nope. We want for notes. Books are
Mine was.
I use mine for problems. I use notes every